Welcome to my nutshell video, a cut down version of the main material. Please help by liking the video and subscribing to my channel. If you've seen any of my other videos before, you'll know I'm a procedural programmer learning object-oriented programming for the first time. These videos have been made to run alongside my blog, which contains much more information and insight into the things I'm learning. This video is one of my shorter ones. I call these nutshell videos. The subject is static methods, static classes, and we will also touch a little bit on the singleton pattern. The video has been made to run alongside my blog, which covers the ideas in much greater depth and I think is definitely worth a read. I have put a link to the blog in the description below. The first thing we are going to look at is static methods. To do this, we'll write a small program to help compare the differences between static and non-static elements. We'll come back to the meaning of words like static and instance shortly, but having the code will help to understand the ideas. Let's create a class, and call it my class. Then within the class we will create two integer variables. Both variables are private, meaning that the code outside of the class cannot access them directly, and if you notice, one has been marked as static. The static variable we will give a default value of 100. The other variable, which we will call the instance variable, isn't given a default value. The reasoning will become apparent as we write and test the code. The next thing is to create a constructor. For now we just accept that the constructor is a routine that executes whenever a new object is created from a class. We will cover constructors in a later article. Within the constructor we will do two things. The first is to increment the value of the static variable. We will talk about why we have done this later. The second is to give our instance variable a value set by the external program. Each time a new object is constructed we will set the instance variable with a unique value. The reason for this is to demonstrate that each instance has its own separate copy of the instance variable. We will then complete the class by creating two simple methods that write to the console. The first is a static method. The second is an instance method. Now our class is complete, we will write some external code to use the functions we created. The first thing we will do is to write some code to instantiate two objects from a single class, like we've done many times before. When we run the code we can see that although the same class has been used to define both objects, the objects themselves are independent entities. We can demonstrate this by showing the values of the instance variables which we set when we created them in the console. You can see that they have different values. Object 1 has a value of 1, and Object 2 has a value of 2. It's worth noticing that in Visual Studio, for each instantiated object, you cannot see the method which has been marked as static. So other than not being able to see the static method, everything looks normal. So what's happened to the static method? When we marked it as static, the compiler in effect removes the method from the instance objects and keeps it with the class. We can still use it by accessing the class directly. This is a very important concept. The animation shows how two independent objects have been created in memory but neither had a copy of the method that was marked static. However, we can still access the static method that belongs with the class by calling the class itself. Now we have this idea in place, we can test it. First off, we have just shown that the code marked as static still exists, but inside the actual class, and this code can be executed. When we created our first object, the constructor set its copy of the instance variable to 1. It also incremented the static variable by 1. Because this second variable has been marked as static, it belongs to the class and not the object, so the value is now set to 101. It's updating a variable that does not exist multiple times in instances of the objects, just once with the class. We then created our second object and the constructor set its copy of the instance variable to 2. It also incremented the static variable by another 1. Again, because this second variable has been marked as static, it belongs to the class and not the object, so the value is now set to 102. Finally, we can show the value stored within the two objects, and demonstrate that they are indeed unique. As a final check, we can run the code in full and see exactly what's happening. If you remember from earlier, the variable marked static, which belongs only to the class, was initially set to a value of 100. This happens as soon as your code starts running. It doesn't rely on other things being created during the course of execution in the same way objects do. Object 1 was then created from the class. Object 1 receives and stores its own instance copy of a variable which we set to 1. As the object is being created, its constructor increments the value of the variable that belongs just to the class, so it now has a value of 101. Object 2 was then created from the same class. Object 2 receives and stores its own instance copy of a variable which this time we set to 2. Like before, its constructor also increments the value of the variable that belongs just to the class, so it now has a value of 102. We have seen the common static variable incrementing, Now we can display the values stored within the objects themselves and check that they are as described above. You can see Object 1 has a value of 1 and Object 2 has a value of 2 as expected. The big question is, when do we use static methods? Well, let's say a method in a class performs a strict set of defined operations, and after the operations have been completed the method returns a result. Let's also say that the operations and result of the method are not linked in any way to the data relevant to the particular instance of the class. A common example of this seems to be the square root function. The square root of a number is the square root of the number. It doesn't rely on data that belongs to the instance of the class. In this situation, there is little point creating a method to calculate the square root of a number in a class and then replicating it over multiple objects. The square root method of each created object will all do exactly the same thing and will not affect the data that is relevant to that individual object. This is the type of scenario where we can use static methods instead. It's created once with the class and belongs to the class forever. Hopefully this gives you a brief idea what a static method is and where we might use it. It is also possible to create static classes that only have static methods. This is very useful if you have a number of helper classes, again, that do one thing and do not affect the data in any particular instance. Lastly, there's the similarity to the singleton pattern, which I hope to investigate in a future article. If you have time, I'd recommend reading my blog where I spend more time on the theory behind static methods and also cover static classes and singleton patterns in more detail. Thank you for watching this in a nutshell video. Take a read of my blog which goes into the whats, whys and wherefores. If you found it in any way useful, please take the time to like and subscribe.